Hello students, welcome to the amazing platform of PW English. So my dear students, today we are going to start another new chapter which is electrochemistry. So we are on the lecture 1 of electrochemistry my dear students. I hope all of you are excited and ready to learn a lot of new things. As I said that physical chemistry is something which is all around you. You just need to find out that which particular concept is being applied here. So today again I have brought a very interesting topic which is electrochemistry. You can see electrochemistry all around you. It is all around you. Let me tell you. Let's discuss about the device in which you are seeing this lecture. You might be seeing in a laptop or you might be seeing in a mobile phone, right? Yes, there is electrochemistry in it. You might have seen batteries, you might have drove on buses, on cars, right? Yes, all the batteries work on the concepts of electrochemistry. Isn't it exciting that we can learn all new things in various ways, right? Yes, so let's start this amazing session. What all topics are we going to discuss today? Let's see that. Today, my dear students, we will be studying first and the most important thing about electrochemical cells. There are different types of electrochemical cells which we need to discuss. So we'll be discussing electrochemical cells. In electrochemical cells, the major two types of cells which we will be discussing are the electrolytic cell and the galvanic cell. And then we'll be studying about the cell representations. Once we learn about electrochemical cells, then we'll understand, we'll learn that how can we represent them and understand everything about them, right? Yes, so let's start this amazing session my dear students. First of all, let's talk about the applications of the topic we are going to discuss, right? Yes, so you might have seen these batteries all around. You might have seen these batteries. You've used these batteries in your remote controls, right? Yes, you might have remote control cars, or you might fight with your sisters or brothers for the television remote control, right? Yes, or in all those you use these batteries, and these work on the electrochemical concepts. Next, if we talk about cars, yes, everyone likes cars. Everyone has ridden on a car some way or the other. Yes, this is also based on electrochemical cells. Let's talk about a little more something which we can relate, right? Yes, you might be studying. I hope you're studying exactly like this. I hope you have a notebook. You're studying from your laptops or your phones. Yes, my dear students, you are using electrochemical concepts right here. Next, if you talk about the mobile phones, iPads, everything works on electrochemistry concepts. And now you are going to be amazed. You might have seen that there is a saying that Chandu ke chacha ne Chandu ki chachi ko chandni ki chowk pe chandi ki chammat se chutney chatai, right? Yeah, you might have heard this somewhere or the other. What is this? This is, my dear students, we talk about the various utensils. We say silver spoon, we say gold spoon, right? Yeah, they are actually, my dear students, electroplated with that particular metal, be it silver, be it gold, right? Yes, and that electroplating concept by which we get these spoons is also based on electrochemistry concepts. And this is the most important thing which you might have seen some time in your life, right? Yeah, you might have seen rusting anywhere. I don't know where you might have seen this, but definitely you've come across something like this. And this is, my dear students, rusting. And we will be studying about this as well because it is also based on electrochemical concepts. Such an amazing chapter which has so many applications, right? Yes. So let's start this session, my dear students. First, let's talk about electrochemistry. Majorly, you can divide electrochemistry in two parts. First is your electrolytic conductance and the other is your electrochemical cells. Okay, electrolytic conductance, electrochemical cells, you will be studying in these forms. Now, my dear students, this is a very easy part. Let me tell you, it is super easy part. It has just numericals. You only need to understand the formulas and you can apply those in the numericals and you will be good to go. Okay, so you need not think a lot about it. Don't worry about it. It is the most easiest part of this chapter, and that is the reason we'll be not discussing this today. We'll be discussing this particular part because this is conceptual. And since we are fresh in mind, we are starting a new chapter, we are excited. So we'll be starting with something which needs a little fresh brain, right? Yes. So we'll be discussing first about electrochemical cells and then about the electrolytic conductance. So if I talk about electrochemical cells, I told you that we can divide your electrochemical cells into majorly two parts. What are those two parts, my dear students? We can then divide it into your galvanic cell and your electrolytic cell. Okay, these are the two types of cells that we will be majorly discussing. Now first let me tell you, just to start this concept, I need to tell you a story, and then you'll relate that story in this whole chapter and you'll understand a lot of things. Okay, so let's start that story, my dear students. You all know how to use mobile phones nowadays, yes, and you all also know that the mobile phones needs to get charged and then they get discharged and then we have to charge it again, and this is the whole process that goes on, right? Yeah. So today we'll be studying this cell and this cell with that particular concept. How are we going to do? Okay, the story goes like this. Imagine you are using your phone. Your phone's battery died. Now what are you supposed to do? You know that you have to charge it, right? Yes, you take your charger and you take the use of the electrical force, electrical energy which is outside from the plug, and you plug it into your phone, right? Yeah, your phone starts getting charged. It will get charged completely, and then you'll just remove the charger, and now you can use your phone sitting anywhere. You don't need to put it into the charger, right? Yeah, till it is not discharged. So for that particular time you can use it anyhow you want. Sometimes you have charged your phone, okay, and you leave it without using it, okay, yeah, but you see that your phone's still getting discharged. Your phone is still getting discharged, right? Yes. Why is it so? You're not using it, still it is getting discharged. What is the reason behind it? So today, my dear students, we'll be studying this, okay. This is the story. Just keep a hold on it. I'll just come back to this story again, okay. Now when we talk about the galvanic cell, my dear students, you need to understand and you need to just, let's say, memorize it, or just accept it, that your galvanic cells are actually the cells in which spontaneous reactions takes place. I am just telling you that the galvanic cell are those cells in which spontaneous reaction takes place, okay. These are spontaneous, okay. I'll explain you the meaning of spontaneous and non-spontaneous. And if you talk about your electrolytic cells are the cells in which non-spontaneous reactions takes place, okay. So let's say non-spontaneous. Now we'll understand the difference between the two. What is spontaneous? Something that happens on its own. You don't need to give it a push. That is known as spontaneous. And something which will happen, but you need to push it. That is something non-spontaneous. Now let's take this example. Let's relate this to you. Okay, there are two different kinds of students, right? Yeah, the first one are who like to study. Okay, they study on their own. There is no force outside force that pushes them to study. Yeah, they like studying. They know that I have a test tomorrow, I'll have to study, so they study on their own, right? Those are spontaneous students. Okay, now there are a few students who don't like to study. The parents need to push them. That study. If you'll study, you'll get good marks. We'll gift you this and we'll gift you that, whatever it is, right? Yes. But they need an external push from their parents. Once they get that push, they'll study, right? Yeah. So those students did study, but They needed an external force, right? Yes. So that is non-spontaneous. So basically what happens is, in galvanic cell, reactions takes place on their own, right? They don't need the external force. That is what is known as spontaneous reactions. If you talk about electrolytic cell, my dear students, in this, though reactions take place, that is true that reactions will take place, but those reactions actually need the outside force to push them to start. Okay, yeah, this is non-spontaneous reactions. So I hope we've got this concept. We are very thorough with this concept. There is no issue with that. Yeah, perfect. Now let's move forward, my dear students. Next, what I want to understand is, I want to ask you a question. I really want to ask you a question, and the question is, whenever we talk about a reaction, a chemical reaction, we discuss a word which is chemical energy. Yeah, I have a reactant. Now this reactant is giving me a product, and I am saying the chemical energy of this reaction is this. Okay. So my dear students, I need to know that what is this chemical energy? What is this chemical energy? Now, if you remember, your answer might be, what I am guessing is your answer would be that whenever we talk about a reaction, we see a delta H value written here. So ma'am, this delta H value, what is this delta H value? This might be the chemical energy. Because for every reaction, there is a delta H value, and that is its chemical energy. This is the thing that every student might think. This is the answer that we get, right? Yeah. So let me tell you, if you are thinking this, you're absolutely wrong. You're absolutely wrong. Why are you wrong? Now you need to understand this. See, my dear students, when you talk about delta H, your delta H is actually enthalpy. This is actually enthalpy. This is not your chemical. This is not your chemical energy. This is the enthalpy of that reaction. It is the enthalpy of that reaction and not the chemical energy of that reaction. Okay. So whenever a reaction, for every reaction, delta H value is given, actually it is denoting you the enthalpy of that reaction. If you talk about the chemical energy, then chemical energy is actually the delta G value. Now you'll just memorize what you have studied in 11th. Delta G is actually your Gibbs free energy. Gibbs free energy. So every reaction has its Gibbs free energy, and that Gibbs free energy is actually known as the chemical energy of that reaction. Okay, yes, I told you this. Now you will never ever forget this particular part. That chemical energy actually denotes the Gibbs free energy. You can call it Gibbs free energy, or you can call it its chemical energy. Now, my dear students, you might remember that delta G for spontaneous reactions. For spontaneous reactions, my dear students, delta G value is always negative. Whenever a reaction has a negative Gibbs free energy, the reaction is spontaneous. Okay, so this means that delta G should be negative. And for non-spontaneous reactions, your delta G value is given to be positive. If for a reaction Gibbs free energy change comes out to be positive value, that means that it is a non-spontaneous reaction, right? Yes. So why I told you this, because every reaction has its Gibbs free energy, and from that you can understand that whether it is a spontaneous reaction or a non-spontaneous reaction, right? I hope there is no issue. Now if I talk about the two types of cells, first is galvanic and the other is electrolytic. Then in galvanic cell, delta G will be negative because the reactions are spontaneous. And here delta G will be positive because the reactions are non-spontaneous. Okay. Now, What I want to make you understand here is one more thing. Now, remember we just discussed a story. We just discussed a story. Now we are using that story here. We are going to understand which cell actually operates when. Now, imagine when you were charging your phone. When you were charging your phone, what were you doing? You were actually using an external force, and that external energy was your electrical energy. And the electrical energy was getting converted into your phone's chemical energy. I hope this is clear. And in that you needed the external force, right? Yeah. So can I say that the charging process is actually a non-spontaneous process, and in that process you actually need a force from outside, because in charging you need a force from outside, and in charging what are you doing? You're actually converting your electrical energy into the chemical energy of your phone. Right? Yes. Once your phone is charged, what will happen? Ma'am, once the phone is charged, now we can say that the chemical energy which is stored in my phone, I can use it on my own. I don't need an external force for it. Now, when you use your phone, you might have seen that light comes on its own. Whenever you on your phone, you see the light. Yeah. So the chemical energy which is stored in your phone has now getting converted into the electrical energy, and that process is spontaneous. You don't need any external force. If you keep your phone without using it, still your battery will get discharged. Why? Because again, my dear students, there are reactions which are taking place spontaneously. You don't need external force for that. So can I say that the charging process is a non-spontaneous process, but the discharging process is actually a spontaneous process, right? So from here it is very, very important to understand that during my dear students, during charging, what is happening? It is a charging is non-spontaneous, means during the time of charging, your phone is actually behaving as a electrolytic cell where non-spontaneous reaction takes place. And what is happening? Your electrical energy is getting converted into your chemical energy. So ma'am, electrical energy is getting converted into chemical energy, right? Yes. Now phone is charged. Now you'll use your phone, it will get discharged. Discharging is on its own, so it is a spontaneous process. So during discharging, galvanic cell, and during galvanic cell, what is happening? The chemical energy which is stored in your phone now is getting converted into the electrical energy, lights. Yes. So I can say that here chemical energy is getting converted into electrical energy, and this process keeps on taking place, right? Yeah, simultaneously. So I hope you've understood the basic concept, because this basic concept was the most important. Other things are secondary. You'll understand everything, right? Yeah. So I hope this is clear with you. Now, if you want to write, my dear students, you can write and then we'll move forward. Okay. So you can write this, pause the video, write this, pause the video, write this. You can pause the video and write this. Now let's move forward. Now, my dear students, we are going to discuss this. What is this? Now we are going to talk about electrochemical cell. Whatever we have studied, now we'll be just writing here and revising all the concepts which we have till now studied. Electrochemical cell can be divided into a electrolytic cell and a galvanic cell. If I talk about an electrolytic cell here, non-spontaneous reactions takes place, right? Non-spontaneous. And here, my dear students, spontaneous reaction takes place. Here, spontaneous reactions takes place, right? Yes. Next, if we talk about non-spontaneous, means your delta G, your chemical energy will be positive, right? Here, my dear students, your delta G will be negative. Okay. Yes. Now let's talk about the conversions of energies. If we talk about the electrolytic cell, ma'am, non-spontaneous means charging process. In charging process, your electrical energy gets converted into chemical energy. right? Yes. And galvanic cell is a spontaneous process, the discharging process. And in discharging, ma'am, what happens? The electrical energy, the chemical energy of the phone gets converted into electrical energy. So chemical energy gets converted into electrical energy. Yes, these are the things which we have studied till now. Now, these are the only things which are written here. You just need to understand them. Okay, so now one by one we'll read and we'll understand all the part. See, in electrolytic cell, we are talking about this cell. The delta G value means Gibbs free energy change for non-spontaneous chemical reaction provided by the electrical energy. See, electrical energy is giving the chemical energy. So this is what it is saying. Example you have been given here. Let's talk about the other point. The decrease in Gibbs energy in galvanic cell, the decrease in Gibbs energy, the Gibbs energy is decreasing, negative value. The decrease in Gibbs energy in galvanic cell, it is also known as voltaic cell, my dear students, is converted to electrical energy. See, chemical energy is getting converted into electrical energy, right? Yes. So whatever we have studied, it has just told you this in a very tricky way, so you need not understand it. If you are not getting it, no issues, my dear students, as long as you understand these two parts. Okay, please write it. I'll have some water and then we'll move forward. I hope you've written it. Now can we move forward? Perfect. Now let's move forward. Now what are we going to do? We've studied the basic concepts about both the cells. Now we'll be discussing each cell individually and understanding all the types of reactions that are taking place. Okay, so if I talk about electrolytic cell, what are the informations that you know beforehand? Okay, let's write those first. I know that in an electrolytic cell, non-spontaneous reactions takes place. Second, I know that delta G value, Gibbs free energy change, is a positive value. Third, I know that, ma'am, what is electrolytic cell? Non-spontaneous, where you need to give the force. This means that which process? Charging process. In charging process, electrical energy gets converted into chemical energy. So, electrical energy gets converted into chemical energy, right? Yes, these are the things which we know. Now, my dear students, we are going to understand a lot of new things. Okay, for that, what you need to know, what you need to understand is, let's imagine a cell. Your electrolytic cells are something like this. You know that since non-spontaneous reaction takes place, so here is a battery attached to it. That is the external force that gives the force. Now, these are the two electrodes. In every cell you will have two electrodes, right? Yes, these are the two electrodes. Now see, since, my dear students, this positive terminal is connected here, so this electrode will be positively charged. I hope you don't have any issue with that. Since the positive terminal is connected, so this electrode will be positive, and since the negative terminal is connected, so this electrode will be negatively charged. Okay, this is the first thing that we can understand. You have, let us say you have molten NaCl solution here. You have molten NaCl. Okay, you have molten NaCl solution here. Now, what happens is, my dear students, you know that opposite charges attract each other. Opposite charges attract each other. So can I say that this Na plus will want to go to the electrode which is negatively charged? I hope this is clear with you, that this positively charged Na plus will like to go to the negatively charged electrode, because positive opposites attract. Yes, ma'am. So I can say that this will go towards the negatively charged electrode, which is this, right? Yes. And since Cl minus is negatively charged, it will try to go to the positively charged electrode. So your positively charged electrode is this, so this will like to go towards this. Okay, yeah. So now what reactions will take place? Now let's see what reactions will take place. See, you know that you have Na plus, and this Na plus is going towards the electrode which is negatively charged, right? Yes. So Na plus will try to take a electron from that negatively charged electrode and get converted into Na solid. As simple as that. Yes, ma'am. So we can say that Na plus will gain an electron and it will go into Na solid. This is the first reaction that I can see will happen. Okay, let's talk about the other. Now we have Cl minus and it is going towards the positively charged electrode. So can I say that this Cl minus will go into half Cl2 plus electron, because it has an extra electron, it will try to lose that particular electron. So these are the two reactions which I can see are actually taking place. Okay, I just balanced this because Cl2 gas, so I had to balance Cl atoms, so I have put minus half, I have put half here. Okay, these are the two reactions which I can see are taking place. I'll just write it a little below. Okay, now what I want to make you understand is here that, my dear students, whenever you talk about electrodes, you have two types of electrodes. You have one anode and you have one cathode, but you don't know which of the two is anode and which of the two is cathode. Okay, so now we'll understand how to find out that which electrode is which. Okay, so for that you need to understand this concept that, my dear students, what is oxidation? First, let's talk about what is oxidation. What is oxidation? Oxidation is loss of electron. Whenever there is a loss of electron, it is known as oxidation. Oxidation is always loss of electron. For example, you have A, it will lose an electron and will form A plus. This is known as your loss of electron. Oxidation is loss of electron. Okay, first and most important thing. The other most important thing is oxidation always takes place at anode, always and always. Okay, so this is the thing which you need to memorize. That whenever you will see electrode, oxidation will always take place at anode. This will never ever change. Okay, let's talk about the other thing. Now we are going to talk about reduction. See, reduction. What is reduction? Reduction is actually, my dear students, gain of electron. It is gain of electron. Whenever an element or an atom gains an electron, it is known as reduction. Let's talk about this. Let's take an example. Imagine A gained an electron. This will form A negative. So this is what is known as gain of electron. Reduction, always gain of electron. Okay. Now, reduction always takes place at cathode. Reduction always takes place at cathode. So you can write that reduction always takes place at cathode. Okay. Reduction always takes place at cathode. These are the few things which you need to remember. Oxidation, loss of electron. Oxidation always takes place at anode. Reduction, gain of electron. Reduction always takes place at cathode. Okay, these are the things which you need to memorize. Okay, if you are clear with this, if you want to write it, you can write it. Okay, yes. Now pause the video, write it, and then we'll move forward. Now see, my dear students, we came back to the here. Now we need to understand which is a anode, which is a cathode. I hope you've seen these reactions and now you can understand that I know that very well, that Na plus is actually gaining an electron and forming Na plus. Na plus is taking an electron, it is gaining an electron. And what is gain of electron? Gain of electron is reduction. Always and always gain of electron is reduction. So this is reduction taking place. If I talk about this, Cl minus is actually forming Cl2 and giving out an electron. This means that this is loss of electron. And since this is loss of electron, I can say that this is oxidation. Now let's talk about the electrodes. Imagine, I know that reduction is gain of electron and it always takes place at cathode. It always takes place at cathode. And I know that oxidation is loss of electron and oxidation always takes place at anode. So this is anode. Now we can see that which is cathode and which is anode. Where your Na plus is going, that is your cathode. Your Na plus is going this side, this is your cathode. So you have found out your cathode. This is your cathode because Na plus is going here and it is actually gaining an electron. If you see for Cl minus, it is losing an electron. And where is it losing an electron? On this electrode. So this is your anode. So this is your anode. Now you can see the charges as well. Now you can see the charges as well. Imagine. Your cathode is negatively charged. So I can say the cathode is negatively charged. Your anode is positively charged. So I can say anode is positively charged. Just see, my dear students, did you need to memorize anything? No, you found out everything on your own. So you just need to understand the concept and you can see that which is cathode, which is anode, which is positively charged, which is negatively charged. You don't need to memorize anything, right? Yes. This is how we study the electrolytic cell. This is how we study the electrolytic cell. I hope everything is clear with you. We first wrote your molten electrolyte, then we saw where does it go, then we wrote the reactions, we saw which is oxidation, which is reduction, wherever reduction takes place cathode, wherever oxidation takes place anode, and we found out everything about electrolytic cell. And this is the most important thing which you needed to understand. Easy? Yes, perfect. If you want to write it, just write it and then we'll move forward. Okay, I hope you've written it. Now, whatever we have studied is written here. If you want to write all the definitions, you can pause the videos and write it. The electrode where oxidation happens is known as anode. We know that. The electrode where reduction happens is known as cathode. We know that as well. Electrodes are the metallic plates. Those metallic plates are actually your electrodes. One of them is anode and one of them is cathode. So pause the video, write it, and then we'll move forward. Next. We always assume aqueous solution. Always and always we assume aqueous solution. Okay. Free electrons. Okay. So here I want to tell you one thing. Before reading this line, I just want to tell you, my dear students, when you talk about your cells, always imagine, you know that here also electron exchange is taking place. Here also electron exchange is taking place. You always need to memorize this particular part, that my dear students, your electrons cannot be exchanged in the aqueous solution. You cannot exchange the electrons in this solution. Exchange of electron will always take place on these electrodes, on the surface of these electrodes. Whether you are gaining an electron, whether you are losing an electron, it will take place on the surface of the electrode. It will always take place on the surface of the electrode. Okay, perfect. So this is the thing that is written here. Free electrons cannot remain in the solution. They cannot remain in the solution. They are present on the surface of electrode. The redox changes can take place at the surface of electrode only. The redox reactions, that is your oxidation and reduction, actually takes place on the surface of electrode only. I hope it is clear with you. Perfect. If you want to write it, just write it and then we'll move forward. I hope you've written it. Now let's move forward. Now, my dear students, we have studied everything about electrolytic cell and we've understood everything about electrolytic cell. Now we are going to study about the galvanic cell. My dear students, galvanic cell is also known as voltaic cell. It is also known as voltaic cell. So if someone asks you about voltaic cell, just imagine they are talking to you about galvanic cell. Okay, now we know that in galvanic cell, what all informations do we know beforehand? Let's write those. We know that in galvanic cell, spontaneous reactions takes place. Spontaneous reactions takes place. Second, we know that delta G value, your Gibbs free energy change, will be negative. And third, my dear students, since it is spontaneous, I can say the discharging process of the phone, and during discharging, what happens? The chemical energy of the phone is getting converted into the electrical energy. So I can say that chemical energy gets converted into electrical energy. Yeah? Yes, ma'am. Perfect. I hope everything is clear till now. Now let's move forward. See, again, I told you that here, my dear students, you have two electrodes. In every cell, you have two electrodes. One is anode, one is cathode, but you don't know which one is cathode and anode, so we have to find out. Since here, spontaneous reactions takes place, since spontaneous reactions are taking place, there will be no battery present. There will be no battery present. Okay. Now, you have to understand this with one particular example. Imagine this is a zinc sulfate solution, Zn2 plus and SN4 SO4 2 minus. So this is your zinc sulfate solution present here, and here, my dear students, let's imagine that copper sulfate solution is present. So copper sulfate is Cu2 plus SO4 2 minus. See, I gave you an example where two different solutions are given. So this particular electrode is of zinc and this particular electrode is of copper. So in your galvanic cell, what happens, whichever the aqueous solution is there, the electrode is also of that particular metal. Since this is a aqueous solution of zinc sulfate, so your electrode is of zinc. Since here the solution is of aqueous sulfate, the copper sulfate, so your electrode is for copper. Okay, yes. Now we know that the reactions are spontaneous here. So how can we find out that which of the following is cathode and which of the following is anode? So for that, you have to trust me for some time, and you'll have to accept if I tell you that which reactions are spontaneous. I'll give you the reason in the next class for sure, that why I said that these reactions are spontaneous and these are not. But for the time being, you need to just trust me and accept that, okay, these reactions are spontaneous. Okay. So what I want to tell you is that your zinc always wants to go into zinc 2 plus state and give 2 electrons. This is a spontaneous reaction. This is a spontaneous reaction. I'll give you the reason in the next class, but for the time being, just accept it that this reaction is spontaneous. So here your zinc is solid state, so here it is an aqueous state. Okay, this is the spontaneous reaction. And if I talk about the copper, my dear students, copper 2 plus in aqueous state always tends to gain 2 electrons and give you copper solid. Here, this reaction is spontaneous. Here, this particular reaction is spontaneous. This happens on its own. Why does it happen? Reason will be given to you. Don't worry. These are the two reactions which take place spontaneously. If I have given you this information, can you anyhow find out that which of the electrode is anode and which of the electrode is cathode? Try that. Pause the video, try that, and then I'll help you out with it. Okay, yes. So now let's imagine, my dear students, if I talk about zinc to zinc 2 plus, I know that for zinc to zinc 2 plus, I know that zinc is losing 2 electrons. Loss of electron is taking place. So I can say that here loss of electron is taking place. And since the loss of electron is taking place, so this is a oxidation process. Loss of electron is oxidation. And here 2 electrons are being gained. So this means that reduction is taking place because gain of electron is taking place. So this is reduction. I know that oxidation always takes place at anode. So this is anode. And reduction always takes place at cathode. So this is cathode. Easy. Right? You need to give me the signs of cathode and anode as well. You need to give me the signs of cathode and anode as well. Okay. So now let's see the signs. Zinc. The electrode where zinc is present, it is a anode. You have this electrode, but I don't know the signs till now. We don't know the signs till now, so we'll study these as well. Okay, so what happened, what is actually happening, I hope you can understand that in anode, I can say this is my anode. At least I can give you this information, that this particular part is my anode and this particular part is my cathode. This is the thing that I have derived till now. This is the thing that I have derived till now. Okay. Now If I see the reactions, see, zinc is getting converted into zinc 2 plus, means zinc solid wants to get converted into zinc aqueous. So here what the tendency is that this zinc wants to go into this state. This wants to go into this state. More and more of zinc solid wants to get converted into zinc 2 plus ion. So they'll be going away in that particular aqueous solution. If you see the other way round, copper 2 plus wants to gain 2 electrons and go into copper solid. So here the system is different. Copper 2 plus wants to go on to the copper form, right? Yes, this is the thing that I can derive. Okay, now what you have to imagine is, my dear students, that when your zinc will go into zinc 2 plus, it will lose 2 electrons. Yes, ma'am. And I told you that electrons cannot be present in the solution. Yes, this means that the 2 electrons will be on the surface of electrode. This means that every zinc going into Zn2 plus, it is leaving its electron on the electrode. So this is how a negative charge gets developed on this electrode. Every zinc goes into Zn2 plus, leaves 2 electron. Every zinc goes into 2 plus, leaves 2 electron, right? Yes. So this electrode has a lot of negative charge. Let's talk about that particular part. Every copper 2 plus will gain 2 electrons and then go into copper. Yeah. See, and I know that the electrons are always present on the surface. So this copper 2 plus will gain 2 electrons from this, right? Yes, will gain 2 electrodes from this electrode and then go into copper. Can I say that it will tend to be into a positive charge? Positive charge, because it is losing a lot of electrons. These electrodes are losing a lot of electrons because copper 2 plus is taking all the electrons from it, right? Yes, whenever A loses an electron, it goes into A plus. So same way, it is losing electrons, so this will be positively charged. From here, you have found out the charges on your electrodes. Your anode is negatively charged and your cathode is positive. Easy. Can we write this? Yes. So your anode is negatively charged and your cathode is positively charged here. Okay, I hope you're clear with this concept. Till now, what we have studied, we just saw the two spontaneous reactions. Seeing the two spontaneous reactions, we saw which is anode and which is cathode. This was anode and this was cathode. I know that at anode, loss of electron takes place. So losing of electron will be on the surface and this will go into Zn2 plus. So this will be negatively charged. And since the Cu2 plus is gaining 2 electrons, so this electrode will be positively charged. I hope till now there's no issue. Okay. Okay. Perfect. Now, what happens is after some time, my dear students, the reactions which were spontaneous stops. Why? The spontaneous reactions are stopping. Why is this happening? Because the reason is that when there will be negative charge a lot, then my dear students, a negative charge concentration will increase. This particular electrode will be highly negative and this particular electrode will be highly positive, right? Yes, so excess of charge has been achieved on the electrodes and that charge needs to be moved. So a very intelligent student actually said that, ma'am, this particular electrode is very negative, that is very positive. What if we connect the two? If we connect the two, there will be neutralization and the reactions will again keep going. And that is a very good thing to say. That is the reason what happens in your galvanic cell. We connect these two electrodes. After connecting these two electrodes, what happens? There is a neutralization because negative charge goes here, and since here are a lot of electrons, so the flow of electron is towards this direction. So first thing that I can say here is that electrons flow from anode to cathode. And in physics, you might have studied that the direction of current is always opposite to the flow of electrons. So the direction of current is from cathode to anode, right? I hope this is clear with you. I hope this is perfectly clear. Yes, ma'am. Till now, we've understood everything. This is the direction of your current. Perfect. Everything was great. Everyone was very happy. What happened? What happened, my dear students? Again, an issue came. Again, the reactions stopped. Why? Now we have connected the two electrodes. Now, why the reactions stopped? Now, let's study about that. What happens is, my dear students, initially, if you talk about here in this particular solution, zinc 2 plus concentration and you have SO4 2 minus concentration, right? Now, imagine when a lot of zinc will keep on coming into the solution, it will form more and more Zn2 plus, but the concentration of SO4 2 minus is same. Yes. So can I say that the concentration of zinc 2 plus is very, very much more than the concentration of SO4 2 minus ion? Right, after a longer duration of time when the reactions have taken place, a lot of zinc has got converted into Zn2 plus, and since the Zn2 plus concentration has increased as compared to the SO4 2 minus, so this particular solution is highly positive in nature. And the same way, let's talk about this state. You have copper 2 plus and you have SO4 2 minus ion concentrations. Now what you need to imagine is more of the copper 2 plus is getting converted into the deposited on the cathode. So can I say that SO4 2 minus concentration is same, but the concentration of Cu2 plus ion is decreasing, and that is the reason I can say that SO4 2 minus ion concentration has increased, is more than the positive, right? Yes. So a excess of negative charge is present here. So a excess of negative charge is present here. So in this particular solution, excess of positive charge is there, and in this particular solution, excess of negative charge is there. And because of these excessive positive and negative charges, the reaction stops again. Now, how can we solve this question? How situation? How are we going to solve the situation? What we do is we connect these two solutions by what is known as salt bridge. What does salt bridge do? Salt bridge, my dear students, actually helps both of them to neutralize, and that is the way we keep on galvanic cell to move, right? Yes. So this is how salt bridge comes into play. I hope it is clear with you. Perfect. So this is the whole setup of your galvanic cell. A few things which we need to notice here, that you have the zinc here. Initially, both copper and zinc were of same width and length. See that, okay. You know that zinc is getting converted into zinc 2 plus. So can I say that with time, if you had zinc this much, zinc will keep on decreasing down. It will get thinner and thinner and thinner. So I can say that the zinc electrode gets thinner and thinner with time. And if we talk about the cathode part, more and more copper is getting deposited, so it gains weight. So we can say that it gets thicker and thicker. So copper electrode gets thicker with time, right? Yes, I hope you're clear with this. Part. Perfect. So this is the whole setup of your galvanic cell. You can understand this very well. I have told you everything very clearly, and also I have written everything here. So you can just note it down. You can draw this diagram, note it down, and revise again. Which the last few minutes part which I have discussed, you need to understand this yourself. That is the best way to understand the whole cell. Okay. So you can draw this. and then you can draw this, and then we'll move forward. Okay, perfect. I hope you've written this. Now let's move forward, my dear students. Now let's talk a little about salt bridge. What is a salt bridge? I told you that salt bridge, actually what was salt bridge, we saw here as well. The salt bridge was this. Yes, now let's talk about the functions of salt bridge. So first and the most important thing is it maintains the electroneutrality. We've seen that it maintains the electroneutrality. So first function is it maintains electroneutrality. The second function is, my dear students, if you see for a galvanic cell, since spontaneous reactions takes place and flow of electron and flow of current also takes place, so you need to complete the circuit. Once the circuit is complete, only then electricity, current can flow, right? Yes. So from here, electrons can flow in this way. But from here, my dear students, you need this salt bridge to complete the circuit, right? Yes. So the second function of salt bridge will be that it completes the circuit. Next is, my dear students, third function of salt bridge is, if you see here, when we discussed about this particular part, excess of positive charge was here and excess of negative charge was here, right? Yes. So this creates a liquid-liquid junction potential. So what salt bridge does is it reduces that liquid-liquid junction potential. So the third function would be it reduces the liquid-liquid junction potential. Right? Yes, perfect. I hope you have no issues with that. Now, my dear students, the next question that is generally asked is, what is salt bridge made up of? What is salt bridge made up of? So now we'll be writing that salt bridge is made up of inert electrolytes. Example, KCl, KNO3, etc. Now, what do they mean by inert electrolytes? Inert electrolytes are the electrolytes which does not react with the aqueous solution ions. If they'll react, then the whole functioning would be ruptured, right? Yes, so we need such electrolytes whose ions do not interact, do not react. So that is the reason you need a salt bridge which is made up of inert electrolytes. And also, my dear students, it is made up of polysaccharides. It is made up of polysaccharides. Example you can say is agar. You can see all these points in your NCERT as well, and you will be asked only this much part. You don't need to discuss it very deeply. Only this much part is enough for you. So you can go through these points and then you are good to go. If you want to write it, then write it, and then we'll move forward. Okay. I hope you have written this. Now let's move forward. Now whatever we have studied, we'll just revise it. Okay. So galvanic cell versus electrolytic cell, how you are going to remember the signs of the electrodes, because most of the questions that are asked in your competitive exams are about the signs, because you generally get confused in those. Okay. So whenever you talk about a galvanic cell, you just memorize any one cell's one electrode. Only one cell, one electrode. Okay, let's say I know that for a galvanic cell, which is a spontaneous cell, there, my dear students, the anode is negatively charged. If I know this, I know all the other three signs as well. I know that if this is negative, then cathode will definitely be positively charged, because one electrode will be negatively charged, then the other has to be positively charged. If, my dear students, electrolytic cell, everything is opposite to the galvanic cell. So if anode is negatively charged, then in electrolytic cell, anode will be positively charged, and in cathode, this will be negatively charged. So if you know any one electrode sign, then you can give the answer to all other 3 electrode signs as well for both the cells. Okay, yes, I hope you're clear with this. You can write this and then we'll practice on some questions. Now, let's practice some questions. Here is a question for you. You have to try this question yourself. What does the question say? The question says that a cell reaction would be spontaneous if delta G value of the reaction is. When is a cell reaction spontaneous? When the chemical energy or the Gibbs free energy is negative. When the chemical energy or the Gibbs free energy is negative, right? Yes, so the negative option C will be your correct answer. Negative, right? Yes, whenever a reaction is spontaneous, its Gibbs free energy need to be negative. If it is positive, then the reaction will be non-spontaneous, right? Perfect. I hope you're clear with this. Now we can move forward. Next question. Next question says that which of the following statement is correct? You have to tell which of the following statement is correct. Okay, read the statements, try the question yourself. First option says cathode is negative terminal in both galvanic and electrolytic cells. See, we just studied that cathode cannot be negative in both the cells. Anode cannot be positive in both the cells. Means that in both the cells, the same electrode cannot have the same sign. They will be definitely opposite. So the first option is wrong. Second, anode is positive terminal in both the cells. No, it cannot be positive in both the cells. It has to be negative or positive in one of the both. Cathode and anode are negative terminal in electrolytic and galvanic cells. See, I only know one thing, that for a galvanic cell, anode is negative. So if anode is negative in galvanic, then it is positive in electrolytic. I know this. And since this is negative, then for cathode, it should be positive and this should be negative. Easy, है ना? See, and cathode is negative in electrolytic. Cathode is negative in electrolytic. Perfectly right. Anode is negative in galvanic. Anode is negative in galvanic. Perfectly right. So yeah, option C is your correct answer. So you just need to apply what you know into the concept. Okay, yes, easy. I hope this was easy. These are the tricky questions which are asked. These are easy, but you generally get confused. Okay, perfect. Yeah, you'll do it. I hope you'll do it. Let's move forward to the next question. The next question says that which of the following statement is correct about galvanic cell? Which of the following statement is correct about galvanic cell? I know that galvanic cell, spontaneous reactions takes place. If spontaneous means delta G has to be negative, and if I talk about spontaneous, then I have to talk about the story. Whenever I talk about spontaneous, I'm actually using my phone. That is the charging process, discharging process, and during the discharging process, your chemical energy is getting converted into the electrical energy of the phone. Okay, so in galvanic cell, it converts the chemical energy into the electrical energy. So option A will be your correct answer. See, such an easy question, right? Yeah, let's move forward to the next question. Next question says that molten sodium chloride conducts electricity due to the presence of. See, my dear students, whenever you talk about the charge carriers, there are majorly two types of charge carriers. One are free electrons and one are free ions. These electrons actually carry the charge on the surface, only on the surface. But if you talk about the solution, then free ions actually carry the charge in solutions, not electrons. Electrons cannot be present in the solution. So if the question is asking that molten sodium chloride conducts electricity, molten sodium chloride is a solution, and if it is conducting electricity, then it is conducting electricity. That means they are carrying the charge due to free ions, because you had NaCl, it is molten NaCl, so you will get Na plus ion and Cl minus ion, which will act as your charge carriers, right? Yes, so free ions, option B will be your correct answer. Option B will be your correct answer. Perfect. Very good, my dear students. Perfect. Now with this, let's end our session today. Since it is a first session, so we'll discuss very few things. We'll be very crisp with the things. We'll stay fresh minded, and in the next session we'll start the cell notation, the cell representation, how to represent a cell, how we can understand that which type of cell is given to you, where is anode, which is cathode, what reactions are taking place on anode, what reactions are taking place on cathode. So there are n number of things that you can derive, and you will be enjoying this session a lot. I am telling you that, right? Yes, I hope you enjoyed today's session. It was amazing. It was conceptually rich, and we practiced a lot of questions. So what you need to do is you need to revise whatever we have studied and try to do all these stories or remember all these stories on your own. Okay, yes, so let's meet in the next session. Till then, you have to keep studying. All the very best. Thank you. Bye bye. Take care.